My name is Manish Gupta, and in this video, I'm going to talk about PaliGemma, which is a versatile 3 billion visual linguistic model for transfer. So let's understand what is PaliGemma and what is its architecture. PaliGemma belongs to the Pali series of vision language models. So here are 4 members of the Pali series so far: Pali 17 billion, Pali X, Palm E, and Pali 3. Pali 17 billion comprised of VIT image encoder and MT5 large language model. Pali X actually had VIT 22 billion parameter image encoder and 32 billion UL2 as the text large language model. PAMI, of course, had the same VIT 22 billion, but the text model was large language model was 540 billion PAM. Pali 3 basically used this SIGLIP image encoder, SIGLIP 2 billion image encoder, which has recently become very popular, along with the 3 billion large language model. So what is PaliGemma? PaliGemma is basically an extension in this series. It is a sub 3 billion parameter model, open vision language model based on the shape optimized SIGLIP SO400 M vision encoder. Okay. So basically it's a 400 million parameter SIGLIP SO vision encoder model combined with Gemma 2 billion model. And that is how overall it is basically just about less than 3 billion parameters. Okay. However, it provides you comparable performance to these other popular members of the Pali series. Just like any other vision language model, it can take one or more images as input along with a text task. This task description could also be called as prompt, question, or prefix. I mean, depending on what you are doing, question answering, so sure, call it question, but image captioning, maybe you just want to call it a prompt and give me a caption for this image, right? So just like other vision language models, it basically takes image tokens separated by a begin of sequence token, and then there are other text tokens ending with the separator. And then there could be other tokens. These suffix tokens are the ones that are generated. So for example, vision question answering, suffix tokens are basically answer tokens. Or image captioning, suffix tokens are actual caption tokens. Okay. So PaliGemma model essentially resizes the image to 224, 448, or 896 before it takes them as input. And so this is the overall architecture. It basically takes an image. The image encoder is a contrastive vision encoder, the SIGLIP 400 million parameter model. The large language model is a 2 billion Gemma model. And of course, it has a linear projection layer as well. Clearly, it takes the text tokens, and these text tokens are directly added or concatenated as input to the transformer decoder. Okay. Now, an interesting part about PaliGemma model is its attention. So when you pass the image and you pass the prefix, it could be prompt, it could be question, and so on. You have like a bidirectional attention in this case. You have full self-attention and not just autoregressive one, right? But of course, when you're generating the output tokens, you generate them autoregressively in the sense that the second token can only pay attention to the first token, and third token can pay attention to the second and the first token, and all the previous image and prefix tokens, for obvious reasons that you cannot pay attention to future tokens anyway. So sure. So, I mean, the output generation is autoregressive in nature, but the input, the image and text tokens, all of them can pay attention to each other. So how are PaliGemma models trained? They are trained in 4 stages: stage 0, stage 1, stage 2, and stage 3, and using several kinds of pre-training tasks that I'll talk about on the right part of this slide. So stage 0 is a typical pre-training, typical unimodal component individual pre-training. So you have the text large language model and you have the image encoder, pre-train them individually. That's stage 0. Okay. And that's practically already done because you have the SIGLIP encoder. You also have the Gemma model pre-trained. So you have it anyway. That's why it's called stage 0. Stage 1 is multimodal pre-training. So it's trained on it's a long pre-training on a carefully selected mixture of multimodal tasks, and nothing is frozen. You basically pre-train the large language model as well as you pre-train, the image encode. Okay. So it uses a slow linear warm-up for the image encoder's learning rate, and this slow pre-training, stage 1 multimodal pre-training, is done at 224 pixels. So 256 image tokens, and text sequence length max of 128 text sequence length with 1 billion examples. Okay, so 1 billion examples, slow pre-training for the image encoder, 224 pixel resolution, 256 image tokens to represent the image, and so on. So and text is printed using 128 tokens. Okay. Stage 2 is a short continued pre-training, but at higher resolution. Remember here the resolution was 224. For the second stage 2, they basically raise it to 448 and then to 896. 448 pixel pre-training is done on 50 million examples, 896 on 10 million examples. Also, they increase the text sequence length from 256 to 512. Okay, that's how they're sort of doing a curriculum kind of a thing. Start with a smaller task and get to a more complex task later. Okay. Stage 3 is transferring the base model to a task-specific specialist. So stage 3 basically is really task-specific. It could stage 2 model really gives you 3 PaliGemma models, 224, 448, and 896 pixel models. And stage 3 basically is really task-specific. You could do fine-tuning, instruction tuning, or chat tuning. You could also adapt these inputs to new scenarios like multiple images or bounding boxes, draw-in images, and so on. Okay, so this is really task specific, but stage 0, 1, 2 are sort of pre-training in a task agnostic manner across 3 different image resolutions. Okay. Okay, so pre-training data essentially comprises of several tasks. So image captioning task across multiple languages, so 100 languages. OCR, optical character recognition task, question answering task, VQA. So where you pass this as actual task tokens, task description tokens, what is the task being done? Okay. Where the question is basically across 35 different languages, but the answer is in English only. Okay, and the questions could also be of different kinds, like listing questions, what objects are in the image, presence questions, multi-object presence questions, counting questions, and so on. You could also have the other way around. So this is a question generation problem. So visual question generation, where you have the English answer, but you generate a question, and the language is specified language code. So for example, Spanish, and then you want to generate a Spanish question for this English answer across 35 languages. Okay. Multi-object detection task. So you can basically say detect, and you can basically give it a whole bunch of objects you want to get detected, and the output, it just coordinates for that. XYWH coordinates for the boxes. Multi-object instance segmentation. So you expect the model to be able to do segmentation by telling it what do you want as a segment. And then captioning tasks. So essentially you can give it a rectangle as it's using its coordinates, x min, y min, x max, y max. And then you can ask it to come up with a grounded caption generation, okay, of whatever is there in the box. So how does PaliGemma model perform? Well, they evaluate performance for all the 3 resolution models. All the 3 models have different resolution, but the sizes are less than 3 billion anyway, 3 billion parameters. Okay. They measure accuracy across image captioning, image segmentation, video input, and the visual question answering tasks, several different data sets. Okay. You can see the results here. Of course, you would expect, typically that the larger the resolution, the better the results you get. That's not totally true. I mean, it sort of saturates at 448 pixel in some ways, but well, there are some tasks which can benefit from the higher resolution as well. Okay. So they actually measure on 40 different tasks that you see them here. And the nice point is PaliGemma establishes state of the art on Coco captions, VQA V2, infographics VQA, and others, but also has very good accuracy on remote sensing VQA, tally VQA, which are really domain specific VQA, visual question answering kind of tasks. It also performs really well on video captioning question answer tasks, such as well as referring expression segmentation task. Okay, so in summary, in this video, I talked about PaliGemma, which is a small 3 billion, less than 3 billion sized open vision language model. It can perform, it can provide state-of-the-art results across a wide variety of benchmark tasks. That's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.